Okay, so we are told that a company has a large number of regular users logging onto its website. On average, 4 users every hour fail to connect to the company's website on their first attempt. So, Part A asks us to explain why the Poisson distribution may be a suitable model for this case. What we have in this situation is we are measuring the amount of current occurrences of something happening over a period of time. And the most important thing here is actually the users failing to connect happens randomly or independently of each other. So what we're going to say is just something along the lines of connecting occurs at random while counting the number of occurrences in a time period, in a specified time period. Okay, let's just smarten that up a bit so we can read it properly. Okay, so you just literally get one statement mark for something along the lines of that we have stated there. So it's not often they ask these questions, but just be prepared to perhaps explain. So more importantly, part B, we want to find a probability that in a randomly chosen 2-hour period, then we're going to find out these probabilities here. So first of all, first thing we need to do is just actually set up our distribution. So x equals number of failures. And so x is going to be distributed with a Poisson distribution. And that is going to have a mean, well, we said 4 users every hour, so over 2 hours, it's going to be a Poisson mean of 8. Okay, so part I says find the probability that all users connect on their first attempt. So actually what we're finding is probability that the number of failures equals 0. So we can either take a reading off the table here or use the formula. The formula is really quite straightforward on this one, because what we're going to do is e to the power of minus 8 times by 8 to the power of 0 over 0 factorial. So all we really have to do is evaluate e to the power of minus 8, which will give us a probability of 0.0003, correct to 4 decimal places. Okay, so part 2. Part 2 asks us to find the probability that at least 4 users fail to connect at their first attempt. So what we're looking to do is a probability x is greater than or equal to 4. Now of course the tables don't read for greater than, I can only do less than or equal to 2, so what I'm going to do is I'm going to do the whole probability, total probability 1, minus the probability that actually we get less than 4. So probability x less than or equal to 3. Now I'm going to take this reading from the table. We're looking to take a reading for a Poisson mean of 8. So if we look across the top and find a Poisson mean of 8 here, just going to highlight that for us. Of course you should be using a piece of paper or a ruler just to make sure that you line up and don't miss that column. Okay, so now I know that it's the furthermost column up until that red line that I'm interested in. What I now need to do is that I'm looking for the probability that x is less than or equal to 3. So I come down, I've found 3 here. What I'm going to do again is I'm just going to rule across so we can see where that applies to for us. And so when I take that reading, we can see we're looking for a probability of 0.0424. Having taken our reading from the table, we're going to get 1 minus 0.0424, which then gives us an answer of 0.9576. 6. Okay, so how do we get our marks on this question? Well, first of all, we get a statement mark for correctly stating our distribution. We can have a method mark if you've used the formula here. If you've used the table, you get the method mark and the accuracy mark just for actually correctly stating this 0.0003. In part 2, we get one method mark for correctly stating that we can find this probability of x greater than or equal to 4 by doing 1 minus probability x less than or equal to 3. And then we get our accuracy mark for calculating that the probability is 0.9576. Okay, I hope that all made sense and that you understood it.